Hey everyone, so we already talked about standard units, so units that you can actually measure with some piece of equipment. Now we're going to talk about derived units, and that's pages 17 through 20 in your textbook. So we'll talk about what derived units actually are, and then the two examples, which are volume and density, and we'll go ahead and calculate density. So derived units are combinations of other units. So for example, speed, you might use that in physics. Volume and density are the ones that we'll talk about here. So volume is the amount of space an object occupies. That's its actual definition. We can use a ruler or graduated cylinder. A ruler is perfect if you have a cube shape or a rectangular, or excuse me, cubic shape. Graduated cylinders are good for liquids, but if you have a solid that's an irregular shape, so a piece of clay, for example, you can use water displacement to help you figure out what the volume is actually going to be. So with water displacement, and again, this is where you might want to jot down some notes real quick. With water displacement, go ahead and take a graduated cylinder that's wide enough to fit the object in. Put some water in there that you've measured in. So, for example, it's a 100 milliliter graduated cylinder, fill it up halfway, 50 mils, with water. Put the object in, measure it again. That difference is going to be the volume that this object occupies. So that's water displacement. The units are pretty much any length cubed. All right, so make sure you write that down as well. The specific units that we use here are centimeters cubed. That's also equivalent to a cc, which is 1 milliliter. So if you ever watch those like doctor shows and they say 10 cc's of epinephrine stat. I mean, I don't know, that probably might kill someone. So if your parents are doctors, just let me know. But yeah, so that's what they represent. It's a milliliter of something. Density is the ratio of mass to volume, so we calculate it out as D is equal to M over V. You might have used triangles to help you out with this. Some people struggle as to where to put everything in the triangle. You might have used that earlier, like when you were younger, to help you as a shortcut. You're older and wiser now. Use the formula. D is equal to M over V. The units are typically kilograms over meters cubed. However, in chemistry, use grams over centimeters cubed. And since centimeters cubed is the same exact thing as milliliters, grams over centimeters cubed is going to be the same as grams per milliliter. That's going to be a really helpful hint, especially when you deal with problems dealing with water. Miscellaneous stuff. Density is intensive property. It's independent of how much you have. So density is a great way to figure out what the identity of an object is. It's temperature dependent, meaning at 25 degrees Celsius you'll have a standard table that has all of the density values. And in fact, when we take the Regents table S will also be where we look for density values for all the elements. So I've got a picture of some guy in a tub shouting out Eureka. That's Archimedes. Archimedes was the one who helped us kind of really discover or helped us use density to determine the identity of an object. So back in, Archimedes was a Greek mathematician, so back in about 3 BC, the king had come to him and said, I need to know if this crown is really made of gold. So what Archimedes did was he went ahead and put it into a known volume of water, checked to see how much the water had risen. There he was able to figure out what the volume was, and then he was able to just take the mass of it and then figure out the density. He compared the density of the gold crown, the crown, to the density of random gold nuggets. Even though they were different sizes, it's okay because, again, density is an intensive property. It doesn't matter how much you have or what the shape is, it's still always going to be the same amount for that object. Quick thing down here, bottom right hand side. I've always wanted to try this out too, so if you ever feel like doing this at home, go for it. These are all common objects found at home. So this is a density column, and I've sort of tried it out with like 6 different liquids, but I haven't gone this intense. So pretty much the objects that are all the way at the bottom, they're the most dense. The objects at the top are the least dense. Water is kind of somewhere in the middle in this scale here, but make sure you know this value. The density of water is 1.00 grams per milliliter, or 1.00 grams per centimeters cubed. We usually use that value. Really, water's density will be like 0.9989 or 0.9988, just depending on the temperature of it. But for the most part, use this one to help you out. And again, this is just for water. So they won't give you what the density of water is. You just need to know that or compare it to something else. So here's our example. The king wants to know if his crown is made of pure gold. Archimedes measures the mass to be 440 grams. So as soon as I see this, I see word problems. I need to start writing stuff down. So I know the mass is 440 grams, so M is equal to 440 grams. By using water displacement, he measures the volume to be 31 centimeters cubed. So the volume is 31 centimeters cubed. Is the crown made of gold? And so we know the density of gold's value is 19.3 grams per centimeter. So let's go ahead and plug this in. We know D is equal to M over V. So let's go ahead and put in our values. Our M is 440 grams. Our V is 31 centimeters cubed. And you're just dividing here. So grab your calculator. I'm grabbing mine right now. So 440 divided by 31. You get a lot of digits. Remember, this isn't a big number. It just has a lot of digits. So go with it with me for right now. It's 14 grams per centimeters cubed. We didn't cancel anything out, so we have to make sure we use those units. Box your answer. Well, so if the density of gold is actually 19.3 grams per centimeters cubed, this object that this king has is not actually going to be made of gold. So to summarize, derived units are a combination of several other units put together, and volume and density are the two most common ones that we will use.